The copper atom has 29 positively charged protons and an equal number of electrons in various shells orbiting its nucleus. After filling the first shell with 2 electrons, the second with 8, the third shell with its maximum 18 electrons, the outermost shell of copper is occupied by a single electron. The lone electron is loosely held in its valence orbit and thus can become a free electron. The ability of this electron to freely move away from its nucleus gives the copper atom its current carrying capacity. Let's take a more detailed look at how these free electrons flow when a voltage is applied across a copper wire. Taking a simplified version of a copper atom with its single valence electron, let's distribute copper atoms along the length of a copper wire. In the absence of a voltage, the free electrons in a copper wire will drift in random directions from the orbit of one atom to another. When a voltage is introduced to the copper wire, the electrons can be directed through the wire with the electrons moving towards the positive end of the source voltage. This movement or flow of electrons in one direction is called electron current flow or just current. Materials that have free electrons and allow electrical current to flow easily are called conductors. Conductors, such as copper, have low resistance to electrical current flow and thus are used extensively in electrical circuits.